First of all, I'd like to say sincere thanks to my sponsors, the South of England Agricultural Society, an absolutely fantastic society which gave me an awful lot of support. I was there sort of several times, giving talks, giving lectures, and the amount of feedback I received from them was truly grateful. Just to go on a little bit about sheep genomics, we can perhaps start with a little bit about me. We run over 2 sites, almost 100 miles apart. By far the biggest site is not Dorset, it's actually West Sussex. It's 1,400 acres. It runs around 3,000 to 3,500 New Zealand Romneys, and most of the ground is HK7 or HK15 higher level stewardship, so no sprays or fertilisers or reseeding, trying to take it back to a much more natural chalk and grass. Since 2005, we've had a programme of AI and embryo transfers from New Zealand into our Romney flock. In 2006, we formed a joint venture with Derek Daniels from Wairiri. Just a little side note about Derek Daniels, because he's quite an interesting chap. Nuffield scholar. His farm supplies almost 4% of the rams to New Zealand. He sells on average just over 3,500 rams per year and operates a total flock size of around 22,000 animals. So really, really big player. We flew over our first 2 live export rams in 2007, and as of now we've flown over 24 rams in total. I wanted to chat a little bit quickly about estimated breeding values. We won't sort of stay on it too much. We are the largest performance recorded flock in the country, I believe. We performance record over 1,700 animals on the Signet system, and what that basically means, it gives you a scorecard for each animal. So there's a range of traits that you're desirable in an animal. How many lambs does it give birth to, what its mothering ability is like, what its carcass conformation is like, etc., etc., etc. And what EBVs really do is try and take information from that animal. It takes information from its cousins, its grandparents, multiple generations, pulls it all together, blends it all in, and you end up with a figure of how likely, in this case, that little lamb would be to give you a set of twins or give you a single. That's kind of a fairly straightforward. The other thing to note with EBVs is there's an accuracy figure next to it. So if you have images, for example, with that little lamb, if he's got multiple generations, if he's got hundreds of cousins going back many, many years, you'd have a relatively high feeling that he's going to be good. If this was the first time you ever recorded him and you didn't know anything about him or his family, the accuracy level on the EBV is tending to be fairly low. Well, my Nuffield started back in 2011 by a talk that was given at the Sheep Breeders Round Table by Dr. Alex Ball. He gave a fantastic talk that must have gone on for about an hour, basically explaining all about sheep genomics, about the fantastic work Australia and New Zealand are doing in terms of genome mapping, identification of genes in the DNA structure of sheep. And he finished it off with a rather typical Aussie comment that, and the best part of this technology is none of you buggers in the Northern Hemisphere are going to be able to use it, because this is all Southern Hemisphere DNA and Southern Hemisphere genetics. What he didn't perhaps realise is we actually have got our own Southern Hemisphere flock in the south of England. So genomics and the technology he was talking about was going to be something we could look into and potentially utilise. So I've talked a little bit about genomics and genomes and lots of complicated words like that. I thought I probably should give a bit of an explanation, because it sounds really technical, but actually it's really easy. Now, you, me, anyone can take a DNA sample from a sheep and have its genome analysed, get a complete breakdown of its DNA structure. That's not tomorrow's technology, that's something that's already being done now. We can do it, it's about $400 for the test. The problem is, like in the screen where I sort of took a screenshot of a computer doing it in Australia, it doesn't really give you very much. It just gives you locations, random locations of genes. What you need is some way to link those genes back to a trait. So, for purposes of this analogy, instead of that computer screen, let's imagine that actually it's just a series of random words. So each of those words represents a gene. Now, like I said, we need some way of linking those genes back to traits, and that's really where Australia and New Zealand are quite far ahead. In New Zealand's example, they run a central progeny test in flock, which is 5,000 animals, very highly, very accurately recorded, that have all been genotyped. So what we can find, or what they did in effect, is We looked at their 5,000 animals, and if we looked for high growth rates, for example, they'd take the top 50 to a top 100 animals, they'd know all the DNA structure of it, and we'd overlap all the DNA together, and they'd start looking for areas of the genome that are the same in all of those 50 animals. And what you'd find, highlighted there, is certain genes always seem to be present in those top 50 animals. And as you go on and look at it even deeper, you get even more of the genes, until eventually you end up with a gene combination for high growth rates out of all that mist and confusion. Now, New Zealand currently offer the world's only commercially available genomics test for sheep. There's 22 key performance metrics for animals with a very high percentage of New Zealand genetics. There's several barriers before you're able to use the test. As I say here, you obviously need a lot of New Zealand DNA. You need DNA that links back to the calibration flock where the original records were used, and you need to be recording on the New Zealand SIL system. So we were very fortunate. We obviously have a very, very high percentage of New Zealand genetics. The rams and lambs born this year were perhaps sort of 15, 16 New Zealand genetics. We record on the SIL system, and also because we import directly from Derek, he's got an awful lot of DNA floating around, and so his flocks actually contribute directly back to that calibration flock, which puts us in an amazing privileged position, if you like. I believe we're probably one of the only flocks in the Northern Hemisphere that's actually able to link into this technology. I won't go through them now, but I did mention the 22 key performance metrics, split into 4 different areas: production, wool, meat yield, health. Some of them are appropriate for UK or European farmers. Some of them, like facial eczema, aren't really a problem in the UK, and so are relatively little use to us. But I wanted to go on and sort of try and explain how we've incorporated this technology into our farming operations a little bit. Now, the first example I wanted to give is these 4 ram lambs here. Traditionally, we don't single cymate and we don't use ram lambs. It's a fantastic way to increase rapidly the genetic gain of your flock, use very young animals, really try and sort of hit the accelerator in terms of genetic gain. The problem, as we discussed before with the EBVs, is they tend to have very low accuracy rates on those traits because they're just not very old. Where genomics gives us an advantage now is every one of these animals, their sire, has been fully genotyped. We sort of sent 18 samples across to New Zealand, 17 of them from our recorded New Zealand tups, but one of them was from a UK-born 8147. We can talk more about him later. So we effectively know 50% of the genes those animals are carrying, because 50% of your DNA comes from your dad, whether you like it or not. We talked just a minute ago, 8147. This is the sort of second example where we're starting to use this technology. He's a real interesting case. Like I said before, we record on 2 different systems, UK-based and a New Zealand-based system. On both systems, completely independent of each other, operated on computers, opposite ends of the world. He was coming up as an exceptional animal, really, really high quality genetics. What was really interesting was we then sent a DNA sample away and had him fully genotyped. So we understood then the complete gene range that he's carrying. So, and that came back exceptional as well. So we were very fortunate to have 3 separate systems, if you like, all telling us what a great animal he was. And that really gave us the confidence to kind of go to town on him a little bit. So this year we put him in with 90 ewes, first of all, for 1 cycle. He's getting hooked out of there next month, and he's going in with another sort of 70, 80 ewe lambs. Really just, he's got that good genetics, if you like. We want to try and incorporate as much of that into our flock as possible in the shortest possible time. Because being a sheep, he'll probably break his leg in a rabbit hole or something like that. Yeah, the next example is New Zealand Romneys aren't terribly popular in the UK yet. They're still somewhat of a minority breed. And as a breeder, it's a great thing to be able to compare yourself against your peers. And so we find ourselves in a situation where we haven't really got anyone to compare ourselves against. By doing this gene technology and actually linking back to New Zealand and looking at their gene structures and what their genes, the genes their rams are carrying, it gives us a tremendous example to be able to actually benchmark our stock against the very best in New Zealand. So if you imagine for a second on that graph, the tests are $400, so no one tests the most rubbish animals, if you like. Everyone always tests their best. So from a natural population curve like that, you're only ever going to be testing your very best animals. And what we found is when we submitted 8147, in terms of some of its meat yield characteristics, it was top 5%, top 10%. Not top 5% of the breed, top 5% of the top percent that are tested. I mean, it was a really exceptional animal, maternal animal, carrying tremendous amounts of terminal traits. It was really, really encouraging. And yeah. So, finally wanted to talk about genomics, talked a little bit about how it's working, and I wanted to give a little bit of proof that it actually does work. Now this is real data taken from our farm. It's 2 natural distribution curves of lamb weight at 8 months. The red dotted line is the lamb weights from animals sired by our 2 top animals in terms of the genes they're carrying. And as you can see, a much higher concentration of higher weights around the mean, and on the bottom end, a lot lower number of lambs that had very, very low weights. Black natural distribution curve shows our worst 2 animals for the same thing. And you can kind of see there just the step change in difference. And that's not, this is real data from our farm. This is with no EBV influence at all. This is just purely based on the genes they're carrying. And it just goes to show the incredible power this technology is going to have to really try and fast forward your genetic gain. That's it, thank you.